The city of Geneva is in celebratory mood. It's the home of CERN, the European Laboratory for Particle Physics, which is running up the flags of its member states to mark 50 years of dramatic research into the mysteries of our universe.
Au début du festival de Genève, eh bien, nous allons célébrer le Big Bang.
The mayor has decided to honor the occasion with a spectacular pyrotechnic impression of the Big Bang.
Le Big Bang.
Ah, Big Bang! Ouais.
Oui.
Oh, did you?
Oui.
I know, yeah, it's a story about the creation of the universe.
Je sais pas. Ah oui, le Big Bang, c'est cette espèce de grand truc qu'ils ont au CERN.
Le Big Bang. Il y a quelques millions d'années en arrière, une grosse météorite a atteint la Terre.
C'est le Big Bang.
As the celebrations echo round the vineyards and pastures of the countryside that lies between Lake Geneva and the Jura Mountains, one can be forgiven for wondering what all the fuss is about. Well, beneath these tranquil fields and in nearby laboratories, there's a very different world. Back up on the surface, the main CERN complex is at Merin, just to the west of Geneva. It's home to many hundreds of scientists, engineers and students from CERN's 20 European member states and visitors from all over the world. With the backdrop of Mont Blanc, ideas are exchanged late into the night.
You measure 4 different temperature points if they lie on one curve.
No, I said we're doing the same thing with the Babar diamond. It's exactly the same. These are hard measurements to make.
Je ferai la position puis je te dirai.
You've seen neutrinos?
Well, not with my eyes.
But how did this global center of creative energy come into being? Half a century ago, Europe's scientific community came together to found a laboratory for particle physics in an attempt to bring about a new renaissance in European research. Adding their weight to its formation were the leading physicists of the day.
Le célèbre professeur danois Niels Bohr, son collègue britannique Sir George Thomson, l'allemand Dr Werner Heisenberg et les plus illustres atomistes des principaux pays d'Europe. Pour la France, le haut commissaire à l'énergie atomique, Francis Perrin, successeur de M. Joliot-Curie.
Their mission was no less than to understand the ultimate nature of the material world that makes up our universe.
Seul un laboratoire bien équipé attire les physiciens expérimentateurs, évite la dispersion des talents européens et suscite l'apparition des forces latentes.
The Second World War had not long ended, and it was felt that such an endeavor would help bring warring nations together and attract European scientists to stay in Europe.
Le prix Nobel de physique, M. Félix Bloch, a présidé la cérémonie de la pose de la première pierre de l'Institut européen pour la recherche nucléaire. Grande date dans l'histoire de l'Europe.
But its birth was not without problems.
The beginning of CERN was very difficult, and this is forgotten nowadays because the past always looks bright. It was very difficult to agree on what the role of such a laboratory should be, where it should be. In fact, you can read in the minutes that during these discussions, one of the delegates broke down weeping.
One of the key figures at its birth was Isidore Rabi.
Rabi was involved also in building the atomic bomb in the States during the war. And he gave a speech here and said the establishment of CERN is a certain compensation for what physicists have done to building the bomb. Now the same physicists think they've founded something for peace.
By the mid-1950s, local villagers were getting a taste of the sheer scale of what was going on. The first of CERN's epic transport operations was underway, operations that now have become part of their lives. Working as a newly married couple on the first experiment were Maria and Giuseppe Fidecaro, who still have offices in CERN today, where they write and help with data analysis. Although they joke about their age, they are still as excited as anybody to see new results.
Well, I was very happy to be here. New place, full of enthusiasm.
Standing on the site of that first experiment, details are still being agreed.
Not but the structure of
yes,
like
structure.
this.
Their first accommodation was the wood-built Cointrin barracks at Geneva Airport. With slide rules their only aid, they began their work. And just 1 month after switching on the beam of the synchro cyclotron, Giuseppe was announcing important results. Progress was relentless in penetrating deeper into the secrets of matter. In 1959 came the proton synchrotron.
Moment historique, mise en marche du plus puissant briseur d'atomes du monde, mise au point par un savant du CERN, projette une bouteille de champagne contre le mur de protection de l'anneau du synchrotron, dont la mise en marche est symbolisée par des effets de lumière. Monsieur Oppenheimer des
The
États-Unis.
PS fired a single beam of protons into a target and is still in use today as a feeder for larger instruments. By applying greater energies and developing precision instruments to capture and analyze transient events, an increasingly large menagerie of elementary particles began to emerge. The 1960s, 70s and 80s saw a relentless increase in the size and sophistication of the experiments, always pushing technology and human ingenuity to the limit. Nobel Prize winner Jack Steinberger is in no doubt about the huge significance of the Gargamel experiment.
It just made for me, the most dramatic discovery which was made at CERN in particle physics.
The discovery in 1973 was the first evidence that two of the four forces of nature, the weak and the electromagnetic force, were in fact originally one force, now renamed the electroweak force.
Very important theory, very beautiful theory.
That is to be compared with the...
And in the packed CERN main lecture theatre in 1983, Carlo Rubbia, following on from the work of Abdus Salam and his colleagues, announced the discovery of the carriers of the weak force, an achievement that won him and another CERN colleague, Simon van der Meer, the Nobel Prize. With unstoppable momentum, CERN had already begun what was at the time Europe's biggest civil engineering project, the Large Electron-Positron Collider, the LEP. Deep underground, 27 kilometers in circumference, straddling both Switzerland and France, it would be the Lord of the Rings. In spite of its size, the LEP's instruments had to be constructed to an accuracy of 0.1 of a millimeter, and even allow for the small tidal movement in the surrounding rocks as the moon passes overhead. Outlining his vision for CERN today is the Director General, Robert Amar.
We have more missions than just one. 4 missions are important for CERN. One is research and making discovery. Second is training and education, which should take attention to young children, to high schools, and doctorants, and so on. And the third mission, to me, is transfer of technology. What we are doing in developing our tools should be the interest of the society at large. And at the end, the fourth mission, which is connection between different kind of people from different countries, from different religious, different political system, to help them to have one common language, which is science.
In seeking answers to questions about the universe, CERN is building the largest, most powerful collider the world has ever known. So powerful that at the moment of particle impact, hitherto unimaginable temperatures will be reached. How will they achieve this? Using the 27-kilometer tunnel that contained the LEP, the Large Hadron Collider, known as the LHC, will use a battering ram nearly 2,000 times more massive than the old electron and positron. The proton. Responding to a massive electrical kick, the proton, having an electrical charge, begins to accelerate. Moving in the opposite direction are other protons, traveling in an adjacent tube. By the time the proton has been accelerated by a linear accelerator, gained energy circulating around two synchrotrons, and been injected into the Large Hadron Collider, its speed is approaching the speed of light. In this apocalyptic jousting tournament, the lead proton is not alone. Each proton group numbers more than 100,000 million. In one of the LHC's 4 giant underground detector caverns, their two paths converge as their Armageddon approaches. The energies created at collisions in the LHC have never occurred since the Big Bang itself, and some of the particles released have not roamed free since that time. It's then the task of the LHC's massive detectors to try and unravel the shower of debris from these collisions. This demands computer power hitherto unseen on the planet. Wolfgang von Ruden heads a team pushing the pace to the limit to provide the computational power needed by the LHC at switch on in 2007.
So I'm looking forward actually to get the next generation of the stuff in that we really can fill the wire, you know, getting a 10 gigabit per second. That is limited by the internal bus of the machine.
Limited by the bus?
The amount of data we're going to generate at LHC is enormous. If you look at the total amount of information produced worldwide, the LHC itself will produce about 1% of the total information of the whole world. So here you see a typical setup of some of our normal compute nodes. We are expecting by the year 2007 to have something like in the order of 5,000 PCs of the fastest model which will be available at that time. So today it would mean more than 20, 30, 40,000 PCs of today's power. Now this is only at CERN. But then you will have the same amount in all these various computer centers around the world. We are talking about at least 10 to 12 large computer centers and maybe 50 to 70 smaller computer centers.
This new supercomputing network will be known as the grid. Indeed, the computing needs of high-energy physics always exceeds the existing technology. To service the needs of the LEP in the 1990s, CERN created the World Wide Web, now part of our daily lives. Who knows what benefits the grid will bring? As well as pure research, the Director General has set training and education as his second goal.
Now, if you have a superconducting material, there is no resistivity.
Each summer, CERN fills with students from all over the world who learn something of the excitement of particle physics.
The main reason for building the LHC is to find the Higgs particle, the particle which is responsible for the mechanism that generates mass.
Sylvain Leconte, for example, is a French engineering student working on an LHC detector and between lectures relaxes in his own way. CERN also holds courses and summer schools in other member states, South America, Asia and the Middle East.
There are smart people everywhere. For example, one of the leaders of one of our experiments started off life on a hill farm in Kenya. Abdus Salam himself started off life in a small town somewhere in the deserts of Pakistan. We just don't know where the next big breakthrough is going to come from.
CERN's third mission is to make its groundbreaking technology available to benefit the outside world.
One area in which particle physics and CERN has helped mankind is in the biomedical field, and one of the key technologies being used is the PET, which is the positron emission tomography. This is the key tool for diagnosing cancer, and the origins of PET are steeped in particle physics, and CERN was right at the forefront in developing crystals, image reconstruction, and some of the electronics.
At present, CERN is helping to explore how the particles it has so much expertise in can be used instead of higher-risk X-rays.
If you want to treat a tumor next to an eye or a brainstem or something like this, you can target it very carefully.
And in financial terms, as a result of reaping the rewards of technological innovation, the money put into CERN gives a threefold return. The Director General's final mission is to bring nations together through science.
CERN celebrates its 50th anniversary not only for its scientific achievements, but also for the fact that it has been one of the cornerstones of European integration. Many European states which have been in wars for centuries have put the resources together to create a scientific endeavor which has now proven very successful and a model for many other institutions.
One such institution is in Jordan, where a synchrotron called Sesame is nearing completion. Herwig Schopper, an ex-Director General of CERN, is its first chairman.
Sesame is an international, intergovernmental organization like CERN.
He's keen to encourage CERN's first students from the United Arab Emirates to think about working there.
It's really gratifying to see Israelis, Palestinians, Iranians, Egyptians, Turkish sit around the same table.
Clearly, the political challenges are enormous. But I think what we've discovered at CERN is that if you get a bunch of scientists together working on a common problem, they forget about the politics.
The huge international team working on CERN's Large Hadron Collider are on schedule, and soon the vast energy of the LHC will place the nearly completed detectors on the very brink of the creation of the universe.
In this accelerator, we will collide protons with each other. And in the collision point, we will get a temperature which is 10 to the 16 Kelvin. Now this is 1 billion times the temperature in the center of the sun. Now in the center of the sun you have already roughly 10 million degrees, and this is 1 billion times that temperature. And now knowing that temperature, we can actually calculate at what time the universe had this temperature to see with time we are actually recreating. And in fact, it turns out to be somewhere around between the 10th and 100th of a billionth of a second after the birth of the entire universe, when the visible universe was no bigger than a few centimeters.
Taking advantage of these extraordinary conditions are the LHC's massive detectors.
Atlas is the biggest experiment ever built in particle physics, and behind me here you can see the vacuum vessels of the 8 coils.
Assembled on the surface and then lowered into its cathedral-like cavern, Atlas is being built by many hundreds of scientists and engineers from all 5 continents.
We are all pushed by the same spirit and by the same awareness of being very close to discover something big.
So big that Atlas and her sister detectors are poised to rediscover the universe through new eyes. The subtle differences, for example, between matter and antimatter at the birth of the universe.
We believe that for every 100 million antiparticles, there were 100 million and one particle. And then 100 million pairs annihilated and just one survived. And that is our type of matter.
Then there's the mysterious nature of dark matter making up most of our universe, and about which we know almost nothing. Although Newton described gravity over 300 years ago, its nature is still unknown and may even link us to other dimensions. And the LHC will be investigating the possibility that the particles around us have hidden supersymmetric partners. An ancient phase of matter, the quark-gluon plasma, is to be investigated by the LHC's ALICE detector, where massive lead nuclei will be smashed together.
By heating up this matter, we are going to liberate again these quarks and gluons from their prison, from their proton and neutron prison.
Even the very nature of the interstellar vacuum is under intense scrutiny.
Vacuum has begun to play a very, very fundamental role. A piece of vacuum here and a piece of vacuum there can repel each other. We absolutely don't understand it, but we know it's there. Vacuum, after all, turns out not to be empty.
Then there's a mechanism that a group of theorists, including Peter Higgs, have proposed that explains how particles get their mass.
Maybe our universe is filled with a field which is now called the Higgs field, and this Higgs field interacts with each type of particle in a different way to give it its very specific mass, in a kind of a friction with a vacuum.
All these imponderables are seen as whispered clues to the ultimate understanding of the universe we find ourselves in. Clues waiting to be interpreted in the long tradition of creative thinking at CERN.
There is only one ingredient of creative thought, which is liberty. In order to have ideas, first of all, it's convenient not to know very much. That's why the best ideas are always had by the youngest people. And also to have the liberty to defy everything you thought was right before. If you are faithful in what you know, then you cannot be a researcher. To be a researcher, you must doubt.
We are swimming on the surface of an ocean, and as we're trying to go deeper into this strange world, we encounter new phenomena, and we don't know which are the next surprises waiting for us.
In 50 years, CERN has really done a splendid job for the particle physics community, and I'd like to add my congratulations. It's a cumulative process. It's something you can really only do with a big institute dedicated to this kind of physics as CERN is.